As engineers, we try to look at the world in a different light and attempt to resolve the problems that present themselves to us. We can solve one right here at Ohlone College's campus, our parking structure. Our parking structure, which started construction in 2014, has been extremely useful to students and teachers alike. But as such a modern complex as it is, there's something wrong. With the development of the new buildings which finished this year, parking on campus has been a struggle. Let's remedy that.
Alright, so as you can tell here, we have a nice information board that's actually supposed to tell us the amount of parking spots available in each level of the parking structure. However, it doesn't work, as you can tell. So this is a problem, and the solution we decided to have for the problem would be to go inside of each floor, and above each parking spot inside of each floor, we wanted to put up these photo sensors that would help actually finish what this obviously started, which is to let people know how many parking spots are available in each level.
On each level of this parking structure, we're actually going to install photo sensors right above each parking spot, and that actually, so it's actually going to be connected to a modem, and that modem is going to connect it to Arduino, and that actually sends signals to a web server, which actually going to store information in our Ohlone home web page, where people can actually look it up online to see how many available spots in this parking structure.
P for parking, and then you can see here all the parking information.
Now, before we move on to our solution to the problem, let's look at an example that has already been implemented.
Like the ones you would find here at the Winchester Garage here in Santana Row. This one is a little bit different in design than we were hoping for, but it has the same general concept. These green lights light up when there's a designated area that's open for available for parking. If it's not lit up or signified by a red light, that means the area is occupied and the driver can move on to a different space.
And like my fellow engineers in my group has stated, the real-time counter that is already on campus will be used as it should be, allowing the driver to make a snap decision whether to park in the garage or in one of the lots. And as well as counters for each row, allowing you to make a decision quickly whether to stay on the level or move to another one to find more available parking. Now, how do we as students accomplish this on a small scale? Well, we can use an Arduino unit, which is an open source hardware through a single board microcontroller. This can be encoded in C++, Python, you name it. This is connected to our photosensor and LEDs, computing the data whether it's in an on or off state. This is necessary for the lights to turn either green or red depending on whether the photosensor detects a vehicle in the way. This is connected to a router, which is connected to a modem for an individual server to be put in place. The modem connects to the server, which sends data wirelessly directly to a Ohlone homepage, allowing students to access real-time data of the available parking. Simple, concise, accurate. We are engineers, and we can save Ohlone in 60 minutes.